Picture this. A travel vlogger submits a brief for a 60-second video about hiking in Patagonia. The request includes 3 platforms: TikTok, YouTube Shorts, and Instagram Reels with a tone that's adventurous yet informative. They upload a rough script outline, some keywords, and a few personal photos. Within hours, the system returns a polished vertical video with dynamic captions, natural-sounding voiceover in 2 languages, and a calendar alert that it's scheduled to post at peak times. No manual editing. No back and forth with freelancers. Just one approved brief becoming everything needed to publish. This is the core promise of our automated content studio, turning creative direction into multi-format output without human intervention. The user's input is simple: a text-based brief with optional media attachments, and the output is a full production package: a rendered video file, subtitle tracks, platform-optimized captions, and social posts queued for delivery. The system handles everything in between: script refinement, scene composition, voice synthesis, text animation, and distribution timing. Underneath, 6 tightly integrated tools divide the labor. YumCut acts as the orchestrator, parsing the brief into a production timeline. It dissects the creative intent, splitting the script into scenes, assigning visual requirements, and managing the handoffs between components. When voiceover is needed, Supertonic generates crisp, expressive audio locally, no cloud latency, using its compact 90nm parameter model. For visuals, ComfyUI's node-based generation pipeline stitches together stock footage, 3D elements, and the user's uploaded photos, applying dynamic transitions and text overlays. Whisper quietly transcribes the voiceover into multiple languages, which YumCut then time synchronizes with the video for accurate captions. Postiz-app takes over in the final mile, mapping the video to the user's social calendar and auto-generating engagement hooks like "save for later" prompts. Meanwhile, Coolify ensures the entire stack runs smoothly on the user's own servers, deploying updates and scaling resources without downtime. Each tool's strength is masked by the seamless experience. The creator never interacts with FFmpeg timelines or ONNX runtime settings, they just see the final deliverables. This isn't a Frankenstein of APIs. It's a unified factory where open-source components work like a professional crew that never sleeps. The result? A team that used to spend days on a single video can now test 10 variations in a week, all from one approved concept. No chaos. No middlemen. Just content multiplied. Here's how the data flow unfolds from a single approved brief to a scheduled social post, with each tool handing work to the next in a tight sequence. The journey starts when a creator submits a brief via YumCut's user API. The API creates a project, tokenizes the idea, and splits it into scenes. YumCut's backend then triggers ComfyUI via an internal service call, passing scene descriptions and style parameters to generate visuals. ComfyUI's node graph processes these prompts, outputs frames or video segments, and writes them to a shared storage bucket. YumCut monitors this bucket via webhook, picking up completed visuals and pairing them with the script's narration cues. For voice, YumCut calls Supertonic's local TTS API, feeding it the script text and expression tags like emphasis or soft. Supertonic generates high-quality V files on the host machine, avoiding cloud latency. These audio files are saved to the same storage bucket, which YumCut tracks through file system events. If captions are needed, YumCut routes the audio to Whisper for transcription. Whisper processes the WAV file, outputs subtitles in SRT format, and stores them alongside the project assets. YumCut then merges visuals, audio, and captions using FFmpeg, assembling a final vertical video. Once the video is rendered, YumCut uses Postiz API to schedule the post. It authenticates with a bearer token, sends the video URL and caption text, and specifies platforms, TikTok, Reels, etc., and release times. Postiz acknowledges with a scheduled post ID, which YumCut stores in its database for audit purposes. Behind the scenes, Coolify manages the deployment pipeline. When YumCut or any dependent service needs scaling, Coolify's API adjusts container resources via Docker Swarm or Kubernetes, ensuring encoding or rendering workloads don't bottleneck the flow. Each handoff is governed by strict contracts. YumCut expects ComfyUI to return frames in MP4 or WebP, Supertonic must output 44.1K its WAVs, and Whisper's SRTs need timestamp alignment. Storage entities like the shared bucket are abstracted behind a unified API, while service boundaries keep Comfy UI focused on visuals and Supertonic on audio. This separation lets teams swap tools like replacing Whisper with another transcription service without disrupting the broader data flow. The result: a single brief becomes a multi-platform content cluster, scheduled and ready to publish, with all transformations logged and auditable through YumCut's dashboard. No manual editing, no API spaghetti, just a coherent chain where each tool does what it does best. Start with YumCut as the core engine. Set up a local instance using Docker Compose to handle timeline assembly and video generation. Seed it with a basic brief text input, style preferences, platform specs, TikTok, Reels, etc. Use YumCut's API to ingest the brief and trigger script generation. Here, integration with Supertonic is critical. When YumCut outputs a script, pipe that text to Supertonic's TTS model for voiceover. Run Supertonic locally via its Python SDK, ensuring the output WVV files align with YumCut's expected audio format. Parallel to this, wire up Comfy UI for visual assets. Use its node graph to define a minimal visual pipeline, text overlays, background generation, or basic animations. Export frames or video segments from Comfy UI into YumCut's media directory, ensuring timestamp alignment with the voiceover. Test this loop. Brief script, voice, visuals, assembled video. If any component fails, for example, Supertonic chokes on special characters, patch the API glue layer to sanitize inputs. For background jobs, use Celery with Redis as a broker. YumCut's API calls should queue tasks, text generation, TTS synthesis, visual rendering, so creators aren't stuck waiting on real-time processing. Monitor the queue via Flower, the Celery monitor, to spot bottlenecks. If Whisper is needed for transcriptions, say for captions, slot it into the pipeline post Supertonic. Take the synthesized audio, run Whisper to generate subtitles, then pass those to YumCut for on-screen overlay. Local development uses Docker to mirror production. Run all services, YumCut, Supertonic, Comfy UI, Whisper, in a Compose stack. Mount local directories for models, Supertonic's TTS weights, Comfy UI's AI checkpoints, to avoid redownloading. Test edge cases, non-English text, abrupt scene transitions, audiovisual sync drift. Fix with pragmatic hacks like padding timestamps in YumCut's timeline JSON before upstream fixes. Deployment uses Coolify as the orchestrator. Define apps for each service in Coolify's UI. YumCut on Node.js, Supertonic via Python, Comfy UI with GPU support. Wire environment variables for API keys, for example, postiz for scheduling, and database connections. Use Coolify's built-in Git integration to deploy code changes automatically. For postiz, configure a webhook that triggers when YumCut finishes a video. Push the final asset to postiz API along with captions and scheduling instructions. Monitor with Prometheus Grafana. Track metrics like video generation time, API error rates, and queue depths. If background jobs stall, scale Celery workers via Coolify's resource controls. Keep the MVP focused. One brief in, one video out, scheduled. Avoid over-engineering. Use existing API surfaces. YumCut's user API, postiz's webhook. Rather than reinventing IPC, iterate based on creator feedback, but ship the core loop first. Putting it all together, the stack demands intentional configuration but rewards with full-stack autonomy. YumCut ties the workflow, leveraging its user API by setting API KE and API secret environment variables to automate project creation and status checks via curl or SDKs. To start, developers clone the repo, install Node.js AT+, and run npm install before configuring a PostgreSQL database via database URL. Whisper integrates via Python scripts, requiring pipe3 install OpenA Whisper, and setting Whisper modal path to point to the downloaded model files. Supertonic runs locally with npm install at Supertonic speech and uses Supertonic lang to set default language, though its MIT license allows customization. Comfy UI demands a Node.js environment with Comfy UI output dir specifying render destinations, while postiz-app needs postiz-mongo URI for MongoDB and postiz-port to avoid conflicts. Curls but requires Coolify server URL and SSH keys for server access. Limitations are clear. Whisper's model size requires 8 GB plus RAM for larger configurations. Supertonic's speed depends on local hardware. ComfyUI's Node Graph needs GPU acceleration for complex renders. Postiz's self-hosted version lacks mobile app support, and Coolify's deployment automation skips advanced rollbacks. All projects use MIT licenses except Whisper, Patch 2.0. And while YumCut's API has rate limits for self-hosted instances, Postiz's cloud version includes premium analytics. A developer can start today by cloning YumCut, setting Versal API key for edge functions, and testing the API with curl, authorization, bearer API KE. One might wonder, how does Supertonic handle mixed language text if the lang parameter is omitted? The answer lies in its training data, but the docs recommend specifying languages for consistent results.